My name is Asaf. I work for a company called Flowtown, and we do social media marketing. So we work a lot with Twitter API and Facebook API and Bitly and all the usual suspects. And that means we work a lot with OAuth. And we don't only work with them, we also expose an API. And so we also implement OAuth. So in this presentation, I'm going to talk about it, explain to you what it does, how it works, and how you can use it for your applications. So you get the directive from up there to start building an API. And the question that comes up is, how do you manage authentication and authorization? We're basically imagining this big world where we have millions of users, and there are thousands of client applications, and each user is using multiple applications, and somehow they need to authenticate to the API. That is a problem that was solved a long time ago, basically. This is the HTTP 1.0 specification, and it defines HTTP basic authentication. And we're talking about 96, which in internet years, it's older than you or me. But there's a problem with that. And the problem with that model is we have to authenticate with an application, you have to give that application a username and password, so it can send it over the wire. This is basically what you see here is the username and password. It's not encrypted, it's base64. So it's basically clear text. So let's talk about what's wrong with username and password. The first problem is once I give you your password to my account, you basically own my account, because you can go there, you can change my password, lock me out of my account, do whatever you want. You can start ordering things with my credit card on ThinkGeek, whatever you want. So that's basically what phishing sites do. And one of the practices in application security is you teach users to never give username and password to a third-party app. Second problem with username and password, I connected 24 client applications to my Twitter account. And yeah, I use a bunch of different Twitter clients, but I also have something that backs it up and a search. And I have a bunch of applications that can push to my tweet stream, like Instagram and Zeit, whatever. Imagine that I decided to not use one of those applications one day. I want to revoke access, and I'm using username and password. I have to change the password, and then I have to go and change the password in 23 other applications. So I'm not going to do that. I might change in 2 or 3. In fact, if it's so hard to get rid of an application, I'm not even going to start using your application. So we're back to the situation a few years ago where people were using 2 or maybe 3 applications because they were so worried about the security concern. The third problem with username and password is, unless you're Sony, we all know to not store passwords as clear text. We sold them and we hash them, so nobody can go into our system and steal the password. The reason for that is that some people use the same password everywhere. It's the same password for the Twitter account and their email account and the bank account. And yeah, it's stupid, but people do that. When we have client applications and you expect them to use password, we're basically saying you have to store that password. And you have to store that password in your application and maybe your phone, and some of these are more secure than others. So basically we're just saying the password has to be in clear text all over the web. So username and password has that limitation. You're probably familiar with a lot of applications. This is Hoptoad that use API keys. API keys work around 2 issues. First of all, it's not your account password, so nobody can steal your account. Nobody can order things on your credit card. Second, because the key is generated by the server, you get a different key for each site. So you have one for Twitter and one for your bank account. If you steal one, you can't access the other. But we still have some of the same issues as username and password. One is it's very hard to revoke this. So again, it's the same issue. If I have 24 applications, I have to generate a new key, and then go and change all the 23. There's also no granular access control. Every client application that gets the API key can do whatever the API allows. The last issue is end users don't like that. I mean, we're geeks, so we don't have a problem. We use API keys in a lot of sites, but end users find it very confusing. It's a bad user experience. They don't like it. So the solution to that problem is basically the OAuth specification. There's two flavors of it. I'm mostly going to talk about 2.0 because that's what the code that I'm going to show you implement. If you're using Facebook Connect, that uses 2.0. If you're using Twitter, that uses 1.0. I'm actually going to show some examples from 1.0. They're slightly similar. I'll also talk about the differences. Here's what OAuth is trying to solve. They're trying to make it very, very easy for people to go in and connect new applications. That's the OAuth flow. There's a lot of attention paid to the UI, the user interaction there, to make it easy. You never give away your passwords to the third-party applications. You can authorize with limited permissions, so I can authorize one account to read my stream and another one to also publish to the stream. And it's very easy to go and revoke. I showed you the screen from Twitter. How is it just to go and revoke a single application? In OAuth, the currency, so to speak, is the access token. The access token identifies the end user, the client application, so each client application gets a different access token. That makes it possible to revoke a specific client application. The resource, if you're wondering what a resource is, it can be anything. It can be every single page on your app can be a resource. But then you have to authenticate for every single page. So usually resource actually means the application. Like the entire application would be a resource. You might break it up so your external facing one is one resource and you have internal stuff where it means that's a different resource. And scope. This is an example from Facebook. Here I'm basically authorizing client application to use my account and very limited scope. So I give it basic information that's by default, send it to email and access posts. It can't do anything else. A different application will authenticate for a different scope. It might be able to do different things. This is what it looks like on the wire. So this is basically a very basic AJAX request. Requesting a resource, the response is going to be JSON, and we have the authorization header, specifying the authorization scheme is OAuth, and the rest is just the token. So it's a very, very simple protocol. Just pass that token around, and you're done. With a few exceptions. And OAuth 2 is still under development. Draft 8, which is the one I've shown you here as this OAuth scheme. That's also the one Facebook implements. That's also the one most of the client libraries out there that you'll find implement. The latest and greatest is Draft 20, which is from 2 days ago. And they went through a lot of evolutions, and part of what they did is they broke the spec into two parts. There's the core part that deals with the authorization flow. I'll describe that in a minute. And there are extension specs for passing those tokens around. One is the bearer token. It's very similar to what we just described. You just put the token inside the request. Another is the MAC access authentication. Now this one takes the request parameters and the access token, creates a digest of them, and passes that in the request. And the reason you do that is if somebody takes away your access token, each client has a different secret for signing it. So if I go and take an access token from a different client, I can't use it with my client. So it's an added measure of security. It's something you might want to look for if you care about security, and you can't use HTTPS. If you can use HTTPS, it's not really an issue because everything is encrypted over the wire, and nobody can steal your access token. OAuth 2 is very similar to OAuth 2.0, but only implements the MAC access authentication. That makes it a bit more complicated, which is why you have, if you ever looked at the OAuth 1.0 client library, it's pretty big, because it has to handle the GET request, the POST request, and do all the encryption and signing up and all that stuff. Another thing you can do with OAuth 2 is you can pass the access token as a query parameter. Now, generally, that's not a recommended practice, because what happens is when you put it in the URL, people take that URL and they post it anywhere. They send it by email, they post it on their Facebook wall, without knowing that they're actually giving people access to their account. So that's a security anti-pattern, but it's very useful in a lot of occasions. For example, If you're using command line tools like curl or wget, it's just more convenient. Facebook uses it really nicely in their developer API. They give you a bunch of links, and those links actually make API requests with an access token that's only good for about an hour. So it's also very good for development tools and testing. So we talked about access token, and now we use the access token. The question is, of course, how we get the access token. That's what, when people say OAuth flow, that's what they mean, actually authorizing a client application and getting an access token. That's the conceptual overview of the flow, and I'm going to show you some screenshots for how it works. So I'm going to start with an application. This is application we worked on. It's called Timely, and I want it to publish tweets to my tweet stream, which means that I need to authorize this application to use Twitter. So I'm going to click on that button. When I click on that button, it redirects me to the authorization server, which in this case happens to be Twitter. So this is the client side, and now we're going into the server side. And this is what the server side does. And it has 3 responsibilities here. The first one is it has to authenticate me. In this case, I'm already signed in, so I'm authenticated. The second thing is it has to allow me to verify the application that's trying to connect and what scope it's trying to use. In this case, it can post to my tweets, but it can't read my direct messages. So it's very important that we expose that to the end user so they know what they're signing up for. And the third one, it should allow me to authorize. And when I click the authorize button, what it does is it redirects me back to the client application. And the redirect includes, it's a very, very long query parameters going on there. It includes a bunch more stuff. It also includes an authorization code. So this goes back to the client application with the authorization code. The client application then takes the authorization code and makes a request behind the scenes, you don't see it, to exchange it for an access token. The reason for this double back and forth is security, because this is kind of easy to hack to its redirect URLs in the browser. It gets the access token, and it sends me back to whatever page, because now it's connected. Now it has access to the account. That is the most common flow you see around when you're using applications. If your application is written entirely in client-side JavaScript, there's a shorthand. It's called implicit tokens. In this case, what happens is it's the same flow, so I get redirected to the authorization server, I authorize, and I get redirected back, except the access token is in the document fragment. That allows the client-side JavaScript to pick it up, but it doesn't allow the backend to pick it up. Again, for security purposes, if you read OAuth 2.0, it explains the different security benefits and drawback of each approach. But if you're going there and using, if you've ever seen Facebook Connect, there's some apps that don't have any backend. It's all client-side JavaScript doing the authentication. This is how it works. Fun part, a bit of code. So like I said, we have an application that is basically client-side JavaScript, and it talks to an API, and it uses OAuth to authenticate. This is an example of a jQuery event handler. And basically what we do is we intercept every request, every AJAX request, and we just add a header. So every AJAX request is authenticated. It's that simple. If you're using Ruby, you probably want to look into this gem, OAuth 2.0. It's a very simple protocol, but this simplifies it even further. You can see how easy. It's like 2 lines of code, basically, to get an access token, and it gives you a very simple HTTP API to access the resource with authentication. If you're doing the server side, right, if you're exposing an API and you want to allow OAuth, that's a bit more tricky. That's a library I wrote. It's called RAC OAuth 2 Server, and it's basically a RAC module that you drop into your existing application. It has nice integration for Rails 2, Rails 3, and Sinatra. And what it does is it handles all the authorization flow and accessing the access token. So it takes care of all of that. It doesn't do any of the authentication. So authenticating a user, creating accounts, all that stuff still remains in the application. This just deals with the OAuth protocol. Takes care of all of that. It also includes an admin console that you can use to register new client applications, review how well they're working, revoke them if necessary. Now, the way we use it is because we have the entire UI is client-side JavaScript talking to the server. We don't use your regular session anymore for authentication. We use OAuth 2. So basically, the client-side JavaScript just uses OAuth 2 as if it's another client of the API. And this is an example for what happens when you're trying to sign up for a new account. The client-side JavaScript basically goes to the server. The server then creates an account. That's a normal stuff. Creates an access token, sends it back the access token, and it stores the access token. That's it. So it's very easy to implement that instead of what we usually used for cookie sessions. We store the access token in local storage. For less modern browsers, it falls back on cookies. This is another example. This is what happens when you click on the Forgot Password button. And what we do is we create an authorization code. I talked about that before. It's also known as an access grant. And we send the URL to the user with that authorization code. When the user clicks on that URL, takes them to the site, right? The site has JavaScript, and the JavaScript exchanges the authorization code for access token, which is the second part of the OAuth flow. So it's just using something that exists. And you can only do the exchange once. Each of those authentication code is only good once, and we put a time limit for an hour. So we basically get a URL that's only good for authenticating once, and it's time limited for free. Everything I showed you so far is examples for web applications. If you're writing something that's not a web application, the story is slightly different, but not that much more complicated. If you're writing a desktop or mobile, you can just embed the web UI to do the authorization flow. And you need to catch the redirect at the end. There's a lot of examples out there on the web for doing that, for iOS, I looked at OS 10, for Windows. If you're using command line, you can also do the same thing. You can open up a browser page. The very last step is just this page that shows the user use the access token, and you can copy and paste it into a command line argument or a configuration file. You can also, that's also part of the protocol, you can actually send username password and get back an access token. Now, I said you don't give username passwords to third-party application, but if it's an application you wrote, like it's an admin script, some programs used internally, you can do that to simplify the flow and still use access tokens. And so what I want you all to take from this presentation is basically stop with the practice of asking users to give their passwords to third-party client applications. OAuth is a great balance between convenience and security. It's a really hard problem, and in my opinion, they went with the simplest solution that can actually work. It's a really good experience. I mean, you can look at all the people who connect applications to Twitter and Facebook, and Google is using it, and a bunch of other sites. So we know it actually works on scale with regular people. And you can use it for just about everything. It's not really complicated. Now, if you're going to start either with the client or the server side, you should probably put an hour or two there because it's a slightly different model. I know in the beginning I tripped. I tried to make a regular request, but I didn't have the token and didn't know about it. Putting server up there is also a bit tricky. The important thing for us is, yeah, we failed in the beginning, but once we put it and deployed there and we've been running for almost a year, we had 0 issues. So it's not something that actually complicates your code base for maintenance-wise. And that's about it.